Everybody, I've had a request to go through this worksheet, so I just drew a little diagram. So here we are. So the library door is closed, and so a student puts her books, which has a mass of 500 grams, so that's the mass of the book, through the slot which is 1.3 meters above the floor. The book slides down a ramp which is 2.1 meters long, so that's our ramp. Okay, this is how high the book is falling from. Later on, the librarian picks up the book, so that's the librarian, picks up the book, and she carries it at a height of 0.80 meters across the room, and then she puts it onto a shelf, which is, the book goes there, 2.3 meters high. So for each of the following stages in the book's journey, use EP equals mg delta h. It's actually delta EP. My thing didn't convert the deltas properly. So the triangle looks like this, but supposed to be a triangle. Calculate the change in gravitational potential energy and state whether it is gained or lost. So the first thing we need to know is EP equals mgh, the mass. You need to convert that to kilograms, okay? So if something is sliding down, every time something falls down, it loses gravitational potential energy. Every time something is picked up or lifted up, then it gains gravitational potential energy. So as it slides down the ramp, gravitational potential energy lost is m times g times the height. So that's the m, that's the g, that's the height. You multiply them all together and you get that much. When it's picked up from the floor, again, m times g times h. This is m, g, and it's 0.80 meters above the floor, so you get that much. As it's carried across the room, there's no change in height, so no gravitational potential energy is gained or lost. As it's put onto the shelf, then it's going to be gained because it's lifted up. Okay, so it's again m times g times h, and you get so much. And how much gravitational potential energy does the book gain or lose in total? So the energy lost is 6.5 joules when it slides down the ramp, but it gains 2 lots of gravitational potential energy, first when the librarian picks it up and then when she puts it on the shelf. So when you add these two together, you get so much. And so the difference in the two is the net energy gained or lost. So it's been gained, so you get 9 joules. And this is a totally different question. It's to do with kinetic energy. So a car of mass 950 kilograms starts from rest. If it's rest, then your speed is 0. And it accelerates to a speed of 20 meters per second, and then it slows down to a different speed of 15 meters per second. So use EK is half mv squared to calculate the kinetic energy. Before it starts, it's not moving, so it has 0 kinetic energy. Okay, but when it accelerates, then your EK is half mv squared. So don't forget to square the 20, so you get this as your answer. And when it slows down, it's got a different speed, so that's your half, that's your m, and that's your new speed. And you get this number. So calculate the change in kinetic energy as it slows down. Change means difference, one minus the other, and this delta stands for change in. So this one number minus the other number, and there's your answer. So I hope that made sense, and we are done.